Hi class, I'm going to work through the problems here on your group homework assignment for week 3. Use these sets to answer the following questions. U is the set of letters of the English alphabet. The fact that I'm using a U here, oops, I'm having trouble with my pen. Give me a second. Pen is not responding. There, now it should. There we go. Okay, so given the fact that I'm using U here is usually an indication that we're referring to this as the universe set. I'm going to go ahead and draw a Venn diagram of this. So we have the universe set right here. This represents all the letters of the English alphabet. Then we have inside of it a subset. A is the set of all vowels. And since every vowel is part of the English alphabet, A would be something like this. And then B is the set of consonants. Now we do have some debate as to whether the letter Y belongs as in the set of vowels or in the set of consonants or in both. So I guess you could make a defensible argument for either case. Let's go ahead and say that Y is not a vowel, and let's just lump it with the consonants. In which case, there is nothing that is a consonant and a vowel both. So you would put B as a disjoint set from A, right? Because they have no overlap, because we're assuming Y is in the B column, in the B set. Now, this particular Venn diagram makes you wonder, is there anything outside of A, B, but still in the universe? Or does A and B together make the universe? This is a good question. The set of all vowels and the set of all consonants combine to make the set of all letters. And so it's kind of strange to have a Venn diagram where you have all this, space here that represents, well, maybe which would suggest that there's things in the universe that are not in A or B. Well, since that's not the case here, sometimes it's good just to split the universe up into two disjoint sets like this. And saying, here's A, or A would be smaller, so maybe it's more appropriate to put A over here. Split the universe into two disjoint sets that, when put together, make the universe. Now let's look at set C, the set of letters of the word rainbow. Well, rainbow has both vowels and consonants, so C would definitely be some sort of set in the universe that's in part B. It's in partly in B and partly in A. So this appears to be our relationship between these four sets. Put the appropriate symbol in each blank space. Now remember this, let's zoom in right here. This symbol here is an element of, is not an element of, is a proper subset of, is not a proper subset of. Proper subset meaning that it's a set that's a subset but not contained, but not equal to the set. Let's look at A, the relationship between A and B. And I have to use one of these four symbols. Well, when you're using the element symbols, these two symbols, those are only used when you have a single element on one side and then a set on the other side. If you're joining two sets, especially sets that have multiple elements like A and B do, then you really just want to focus on notations that would join sets or relate sets. So it's either just going to be a subset or a not subset. And in this case, A is not a subset of B because it's not contained in B. There's no vowel, it's also a consonant. Because we're assuming Y belonged in the consonant set, not in the vowel set. To be a proper subset, you would have to have this sort of relationship. B would be here and A would be strictly smaller than it, meaning that there was stuff outside of A but still in B. This is a proper subset relationship, and that's just not the case here with the vowels and the consonants. Let's see, this is a letter, so that's an element. And this is asking us then, so we're going to use an element notation, and is Z in the set of the letters of the word rainbow? In other words, is Z a letter in the word rainbow? And the answer is no, so you would say not an element of. BW, this is a set. There's two elements there, so we're going to use one of these set relationships. And BW is a subset of B. Yes or no? Well, B is a set of all consonants. The set B, capital B, is a set of all consonants, and little b and little w are both consonants, so this is definitely going to be a subset, a proper subset. And B is also a proper subset of the universe. That's also true for A and for C. Here's the letter U. Is the letter U an element of the set A or not? Well, A is the set of vowels, so yes, U is an element of the set A. And then finally, C and B. Well, look at the relationship over here between C and B. If I were to draw it a different way, it would look something like this. This is B, this is C. Since C is not entirely inside the circle B, because there are some letters, like the letter A would be an element of C that's not in B, because A is in rainbow, but A is not a consonant, then we have a non-subset relationship. So we have to put a subset symbol, put a slash through it. Next one, determine the elements of the following subsets. Okay, so A intersect B. Well, A and B are disjoint, because we're assuming that Y is not a vowel, we're assuming it's a consonant. If you made the assumption that Y is a consonant as well as a vowel, then you would probably say that we get a single element that's in their intersection. You might be tempted to say Y is both a vowel and consonant. So it really depends on the argument you're making, but I'm going to fill in these solutions with the assumption that we're categorizing Y as a consonant, not as a vowel. But I leave that to you to, defend your own position. In which case, A and B have nothing in common, so the empty set would be the intersection. A union C. Oh, another way to write the empty set, by the way, is to start by writing the curly brackets, but just putting nothing inside of it. This is just another way to say empty set. Now we're doing A union C. So if I were to do some shading over here for A union C, we want to shade everything that's in C or in A. So we'd be shading all this. And combined, that green blob is A union C. So everything that's in A combined with everything that's in C. So let's start listing them. This says determine the elements, right? Well, everything in A is a vowel. So we have A, E, I, O, and U. And we're treating Y as a consonant, so it's not in the set A. And then we're going to union this with the set C. C is all the letters of the word rainbow. Well, it has 3 vowels in it, A, I, and O, but I've already listed them, so I don't need to list them twice. And then look at what consonants this adds to the list. R, N, B, and W. So we have R, N, B, and W. So this is the union of the two sets. All right, this B with a bar above it means B complement. It means everything that's not in B but still in the universe. Well, everything that's not in B, it turns out that this is really just a set A again. Because A and B are disjoint, meaning they have nothing in common, and together they make the universe. So A, E, I, O, U would be the complement of B. This is A complement intersect C. So in this picture here, A complement is everything that's not in A. So I'm going to shade that. This is everything that's not in A. It's on this side. But now we're going to intersect this with C. So everything in C I shade again. But what did I shade twice? That's their intersection. So I'm going to emphasize that right here. Right? That's the intersection. So we need to have A complement intersected with C is going to give us everything that's in C that's not a vowel. So in this case, that's going to give us everything that's in C that's not a vowel. So looking at the letters of the word rainbow and just list the ones that are not vowels. So the R, N, B, W. This last one is the complement of C intersect with A. Okay, so let's go back up here and delete some of that shading. I'm going to shade once the complement of C, so everything that's outside of C but still in the universe is the complement of C. Let's make that look kind of okay. There we go. and we're going to intersect that with A itself. So now I'm going to shade everything in A. And everything that got shaded twice is their intersection. So I'm going to re-emphasize that. That's just this darker green section is the intersection. So we need to do everything that's in A, which is all the vowels, but there can't be anything that's in C. So I have to remove the vowels that are in the word rainbow. So every vowel, but remove the vowels in the word rainbow, and we get E and U as the only two vowels left. Because A, I, and O were in the word rainbow, so I had to remove those. Okay, that's it for the first task. Let's move on to the next task. Answer the following questions about sets. Justify each answer. Under what conditions will X union Y equal X? Well, remember that there are only really four possible ways that two sets can interact. It could turn out that both sets are the same. So this is X and it's also Y. They're the same set. That's one possibility. Another possibility is that Y and X are disjoint. Something like this, where they have nothing in common. Another possibility is where there's some overlap. And a third possibility is where one contains the other, like this, and one is a proper subset of the other. In other words, they're not equal. So these are your four cases. Either they're the same, which is case one is a proper subset of the other, they have some in common, but also some of their own distinct things, and then they're disjoint. And we have to discover which of these four cases would lead to the union of X and Y just being X again. Well, in the case that's currently on the screen right here, X union Y, well, here's X, here's Y, put them together, and we get the combination of the two greens. And that's not the same thing as X. So this is not a case where X union Y would just be X again. If I do a subset like this and then say, okay, anything that's in X or in Y, so I just get to shade all that stuff, that's everything that's in green there is the union, but that's not the same thing as X. So that doesn't work either. Let's do there we go, where X and Y, one is a proper subset of the other, but in this order. If I shade everything in X or in Y, I really just get this shading again. But this equals Y, not X. So that one we don't like either. And if the two are the same, if the two sets are the same, then their union would just be X again. And another case would be if, what if I switched these labels and said that Y was this one and X was that one, and it was such that Y was a proper subset of X. So then you would say, okay, well, X or Y, anything in X or in Y winds up being shaded this, and that's just X again. So we have that this will be a true statement if Y is a proper subset of X, or if Y is equal to X, or you can combine these and say that Y is a proper set or equal to X. So ultimately this is the condition, right, where X union Y will simply be X again. Question B, if A is in the union of capital A and B, is it true that little a is in their intersection? Okay, so if A is in their union, we just have to, if this is a false conclusion, then we just got to come up with one counter example. Let's say that they have a relationship like this. The union would be anything in either A or B. So if little a is in the union, then little a could be right there. Right, let me just do it this way. But little a could be in this left-hand portion. It could be in capital A, but not in capital B, but it would be in their union. Is it true that A is in their intersection? Well, their intersection is only this part right here. And so it's from this image alone, we can see that A could be in the union but not be in the intersection. So we would say no and use this image here as a justification for that. We just had to come up with one case where A could be in the union, but without being able to conclude that A is in the intersection. Now, it is possible that A could be in both, right? Or I could have put the little a right there, but it's not required. So this is asking, is it generally true that A will be in the intersection? And we can't say that it's generally true. It might be true in some cases, but not generally. If X is a subset of Y, or potentially equal, right, can we always conclude that X is Y? The answer, I think, hopefully this is obvious, no, because you could have this relationship, and this would still, you would still technically be allowed to use this symbol here, that X is a proper subset or equal. This allows for the two sets to either be equal or for one to be a proper subset. So this, saying this statement alone doesn't guarantee that we're talking about the same sets. If we were talking about the same sets, then I would just use the equal sign. So the answer here is no. So and this drawing here supports that, because we would say that X is a subset or equal to Y, but X is not equal to Y. So it's really better to say that X is a proper subset in this case. But as we said in the lecture, given this drawing, technically this is true and this is true, but this is preferable because it relates better information. Is the empty set a subset of every set? The answer to this is yes. The empty set is always a subset of any set, even if that set is the empty set again. And when you say a subset, this allows for the potential equality of the sets. If I said proper subset, then the answer here would be no. And that's something to consider, because this technically is a false statement. You can't put two sets that are equal and put a proper subset notation between them. That's kind of like saying 2 is less than 2. It's just not a true statement. You would need the partial equal sign if you're going to have the same sets on both sides. So it's definitely, if I had put the word proper right here, is the empty set a proper subset of every set, the answer would be no, because this is a false statement. The empty set is not a proper subset of the empty set. But if you allow for a potential equal, then yeah, it really doesn't matter what set you have over here. The empty set is always a subset, proper or equal, of the set, of any other set possible. So let's put a yes here. Yes. Suppose A is a subset of B. Can we always conclude that A is a proper subset of B? No, because right, this allows for a set. Let's say this is A and B both. It's the same set. And so this statement is good. This statement is better. This statement is bad. Right? So we can't conclude just from the statement that A is a subset of B, because that allows for possible equals. But this one here does not allow for possible equal. So we're going to consider the case, right, where A and B are the same set. Then both of these are good notations, although this one's better. But certainly we can't say proper subset in that case. Okay, let's move on to question 3. Shade the Venn diagram corresponding to the set A union B intersect C. So I'm going to use this nice drawing app to do shading, and when I shade something twice, it gets a little bit darker, which is nice. Maybe let's go a different color, red, just for fun. A union B, let's do that part first. A union B is anything in A or in B. So don't shade A. If I shaded A by itself and then lifted my pen and then shaded B, notice that the overlap gets darker. But this dark part in the middle is A intersect B. A union B is anything I've shaded, anything. So it's better just for me to shade this all at once, okay, without lifting the pencil, so that nothing gets darker. So right there that's A union B. And now let's do a different color for the intersection, or sorry, for C. So now I'm going to just shade everything in C. And the intersection would be anything I shaded twice. So anything that was red and then anything that was blue, the overlap got shaded twice, and that's the purple stuff. So now that I've identified the purple stuff, let me go ahead and clear the colors. And what I did shade twice was anything that was in C, but also in A or B. So this would be a good final drawing. A union B intersected with C. How about the complement of B intersect with the complement of C? So I'm going to first just highlight the complement of B. So we have to do everything that's in the universe, but not in B. So it's going to shade a bunch of stuff. I just have to make sure I shade everything outside of B, but still in the universe. So it winds up looking something like this. And then we're going to intersect that with the complement of C. Well, the complement of C is I'm going to shade everything in the universe, but not in C. Yeah, so it looks, something like this. Now, anything that I've shaded twice is going to be in the intersection, right? The blue is complement of C. And so that's all the purple stuff. So in other words, I have to wind up shading everything that's not in B and not in C. It has to not be in either circle, B or C. So my final answer is going to be everything that's not in B or in C. I should say and. It's not in B and it's not in C. The word and is a good word to use when you're doing an intersection, and the word or is a good word to use when you're doing a union. I hope I made that clear in the lecture. So we want everything that's not in B or not in C. Sorry, and not in C, because this is an intersection right there. And that is what I just shaded. That's everything that's not in both. Everything not in B intersect with everything not in C. Let's go to the next one. Write the expression that represents the shaded portion below. And there's a few ways to do this, including what we learned in week 4 is something called a set difference, but we're going to do this without using set differences. We're going to do it using complements, unions, and intersections only. So it looks like if I could figure out a way to, and there's lots of ways you could do this. It looks like a B is going to be doing an intersection with something else. I'm trying to think of a way to shade a few pieces here where what's in orange would be shaded twice. For example, if I shaded everything in B, that would get the orange shaded once, but now I want to get the orange, I want to get a shading that will do the orange a second time. And so if I want to pretty much shade everything except for that middle part. It looks like there's a way I could do this way. Right? It may be helpful to, let me move that shading for a moment, to rethink with a blank one here. So I definitely, it's if I do a B union with something, or I'm thinking do a B union with something, then I will have shaded B once, all of B. So there's my first shading. Let's do a different color for the next part. And then I want to shade parts of B a second time. Notice if I were to shade everything except where A and C overlap. Right, so I do something like this. Well, you know what I should do? I should use yellow and red to get this orange. So let's do everything in B is, there's B, and we're going to union that with everything outside of the intersection of A and C. So everything in the universe outside of that intersection. Okay, notice that if I do it this way, then the things that got shaded twice became orange, and it is exactly what I'm trying to arrive at right here in this image. So how do what would I put right there for what I shaded in red? Well, we shaded everything except what A and C have in common. So if I intersect A and C, but then do the complement of that, you can put this complement sign, by the way, over a collection of things, right? But you can do something like this, A union B, and say what everything that's not in A union B. Well, A intersect C was, I hesitate to do another shading in here, but A intersect C is this little piece right here. But we wanted to shade everything except that, and that, therefore, we're doing A intersect C complement, and we're going to union that with the B. Okay, let me delete that stuff. Let me put this blue shading back into this picture, and let's move this work down here, and this, cancel that. And we have an expression here that will give me that orange shaded region. Now, it's very likely to be other ways you could do this, but we'll just leave that as one option. If you have a different way and you want to, and it's justifiable, great. A recent survey of business people was analyzed to produce the following Venn diagram. Answer the questions that follow. Okay, so this is what I think, how many business people own different kinds of equipment. People who own desktop computers, laptop computers, and fax machines, and then people who are outside all the circles don't own any of it. But it's certainly possible to own all three. That's where the overlap of all three is, etc. So let's see. How many business people owned a laptop computer? Well, we just got a laptop computer is this portion. Right, so we just got to add those four numbers. Right? These numbers represent the 5 is how many people are in this part, the 3 is how many are in that part, the 12 is how many are in that part, and the 2 is how many is that part. So you put them all together, you get that whole circle. And 5 plus 3 is 8, plus 12 is 20, plus 2. Looks like we have 22 people own a laptop computer. How many business people did not own a fax machine? Okay, so now we want to focus on everything that's outside the fax machine circle, right, but still in the universe. And there's only really 3 numbers to consider here, the 7, the 9, the 3, and the 5. Add those numbers together, and that would be how many people don't have a fax machine. So 7 plus 9 is 16, plus 3 is 19, plus 5 is 25. Sorry, plus 24. Make sure I add that right. 5 plus 3 is 8, plus 7 is 15, plus 9 is 24. Okay. How many business people owned all 3 machines? Okay, well, that's just the intersection of all 3 sets. There's the 12 people right there that have all 3 machines. So 12 people. How many business people owned both a laptop computer and a desktop computer? So laptop computer is this circle. Desktop computer is this circle. And whatever got shaded twice are the people who own both. So there's 12 people who also have a fax machine, as well as a laptop and desktop computer. And then there's 3 people who have a laptop and desktop but don't have a fax machine. So that makes for a total of 15 people that have both a laptop and a desktop. 15 people. And finally, how many business people own only a fax machine? All right, so to have only a fax machine means they can't have a desktop and they can't have a laptop. So we're talking about this portion only of the fax machine. And that's just those 19 people that are there in that list, or in that Venn diagram. 19 people. Okay, so that wraps up that task. Task number 5. A study was made of 1,000 rivers to determine what pollutants are in them. Provide a Venn diagram that accurately depicts the following data. 177 rivers are clean. 101 rivers are polluted only with crude oil. So crude oil is one pollutant. Phosphates looks like another one. Sulfur compounds looks like another one. And I think that's it. We have 3 different pollutants. So, and it looks like, are any polluted with all 3? That's something to consider. Let's assume that we have, let's just begin with our basic Venn diagram. That's the triple intersection of circles. And if it turns out that one of these is empty, we put a 0 in that portion. But let's just assume that we have 3 intersecting circles. Okay, so let's do that. And let's identify which circle is which. Let's say that this circle here is crude oil. This circle here we'll say is the phosphates. And this other circle is our other one, which was the sulfur. We'll just say sulfur, the sulfur compound. Okay, and this all exists, of course, within some universe. So it'd be a good idea, let me shrink this drawing down and put it in the context of some universe. I'll put a U there for the universe. Now we know that 1,000 rivers were studied. So whatever numbers I wind up putting in all these little, possible places, including outside, all those question marks have to add to 1,000. So that's something to keep in mind as we move forward. And it says that, let's begin with this first bullet, 177 rivers are clean. So that means they don't have any pollutants of at least not these 3. So we're going to put the 177 figure outside the 3, but still in the universe. 101 rivers are polluted only with crude oil. So that's going to give us a 101 in this portion of our Venn diagram, only crude oil, but not phosphates, not sulfur. 493 rivers are polluted with phosphates. So that means we have 4 numbers to consider inside this phosphate circle. Right, we have this portion, this portion, this portion, that portion. We're going to get 4 numbers in there, and they have to add to 439. Let's just tuck that information away for the time being. Let's go to the next bullet, see if that can give us something conclusive. 72 rivers are polluted with sulfur compound and crude oil, but not with phosphates. Okay, so that's useful. 72 have sulfur and crude, but not phosphates. So that's 72 should belong right here. Crude and sulfur, but not phosphate. 200 and I'm going to circle the ones I need to come back to. The ones I couldn't, or maybe cross out the ones that we were able to put numbers directly into our list here or something. 289 rivers are polluted with phosphates, but not with crude oil. Okay, so with phosphates, but not with crude oil, is going to be these portions. This is phosphates, but not crude oil. So there's 2 numbers that are going to have to add to that 289. And keep that in mind. Let's move on to the next one, see if we can get a definitive number for one of these. 463 rivers are polluted with sulfur compounds. Okay, so that's another issue where this number, this number, this number, and this number have to add to 463. Okay, so we'll come back to that. And the last one is 137 rivers are polluted only with phosphates. So 130, that number we can throw right into this list. Only with phosphates, that puts the 137 right there. Okay, let's see if we can figure out the rest of this from this information alone. Knowing that there's 1,000 rivers is going to be useful. And knowing how many are in, we have 3 bullets that I wasn't able just to put a number right into there. So maybe let's focus on those first. phosphates, but not crude oil. Okay, so I think this is our next one to go with is this number here. 289 rivers are polluted with phosphates, but not crude oil. So that means with this number plus this number have to add to that 289. Now it could be a good idea here, that's the phosphates but not crude oil, yeah. It could be a good idea to put some letters in here that we have to solve for. Like for example, you can put an A here, a B here, a C here, and a D here. We've got to just figure out these remaining numbers. And this bullet that's currently circled tells us that, and let me do a little bit of rearranging so I can give myself some space to do some work. Let's get rid of our universe. That was going over too far. Give me a little bit of space over here. There we go. Something like this. And let's move this whole thing over even more this way. There we go. Okay, so we know that 100, and the way I've labeled this number plus whatever that number is, has to be this 289. So 137 plus whatever C is, has to be 289. So we can subtract the 137 and get C right away. And subtracting 137 gives us 152. Okay, so I can go in here and say that this C, I'm going to leave the C in the picture, has to be 152. Just so that this notation makes sense. Otherwise, if I erase the C, and then it's like, hey, what's this still referring to? I don't see a C, right? So I'm going to leave the C in my Venn diagram. And I've now used this bullet of information. Okay, so that leaves A, B, and D still. Let's see, let's work with this 439 number. 439 rivers are polluted with phosphates. 439, so that's going to be adding this number, and those two numbers. That adds up to the phosphates. So I'm going to be able to make an equation that 137 plus 152, which that gives us this 289 number. So that 289 that we have, which is this number and that number, plus A plus B has to be equal to this 439. And if I were to subtract 289 from 439, that means whatever A and B are, they have to add to B. Let's see, let's remove in bits and pieces. I'm going to remove 39 from 439 to take it to 400. I have to remove another 250 from that, so 150 is my count. 150 are what A and B add together, and I have at least an equation I made from that information. And let's now look at this last information. 463 rivers are polluted with sulfur compounds. Okay, so the sulfur compounds are the sum of these four numbers. So we have 72 plus 152 plus B plus D has to be equal to this 463. And that uses up that information. And we can let's move some of this stuff around. I'm going to circle the ones that when I finally got conclusive. So let's circle that one. I'm not conclusive here yet, so I'm going to leave that as something to work with. Let's go ahead and add these together. That's 224, and remove that from the 463. 224 removed from 463 is 239. Does that feel right? 224 added to that. Yeah, that feels right. Hopefully I'm not doing any silly arithmetic mistakes. Okay, so I know that B plus D equals 239. And then it looks kind of, I've crossed out every bullet. But there's an implied bullet here. We know that the total has to be 1,000. All right, so we get to add up all this stuff. All these numbers, including the A, B, and D, need to add up to 1,000. And I'm going to spare myself doing a whole bunch of mental math, and I'm going to pull up a calculator, which I'll do off screen. But I'll write down the calculation I'm going to do. I'm going to add up all the numbers you see here. So we know that 101, right, just no particular order. The 101 plus that. I'm going to do all the ones that are numbers first. So those are all numbers. 101 plus 177 plus the 72 plus the 152 plus the 137 and then plus the A plus the B plus the D has to be equal to 1,000. Again, I'm not giving myself a ton of space here. Let's shrink our universe down even more and move all this stuff a little bit over just so that I can make this one line of work instead. Plus ABD equals 1,000. There we go. All right, now I'm just going to use a calculator. I'm going to open one. I'm doing this off screen, so you're not seeing what I'm doing here, but I'm going to add those numbers all up. Let me enter what they were. We had 101, 177, a 72, a 152, a 137. Okay, and let me add those up. So we get 639. And then plus A plus B plus D equals 1,000. Subtract 639 from 1,000 is 631. So A plus B plus D has to be 361. And here's where it gets these other bits of information become useful. We know that A plus B, whatever they are, have to add to 150. So I could just replace that with a 150 right there, and then I can solve this for D. So subtract 150 from 361, and we get that D has to be 211. I could have done that a different way, right? I could have, because I also know that B plus D is 239. Right, so I could have changed that to 239 and subtracted 239 from 361 to get A. So we're going to do 361 minus 239, and we get A is 122. And A plus B have to add to 150, so I now know that B therefore has to be 28. Okay, so with a little bit of creative ingenuity, we were able to figure this. Let me leave that work there. We were able to figure out what A was, and then we knew what B was next after that, because B had to be, A plus B had to be 150, so 28 is B. And once you know B, you can figure out what D has to be by removing 28 from 239. And we get D, therefore, was the 211. So this leads to all of our unknowns, and we have now a complete Venn diagram. Now we use the Venn diagram to answer the questions that follow. How many rivers are polluted with sulfur, crude oil, and phosphates? Well, that's the 28 in the middle. The 28 rivers. Right, that's just the part that's overlapping all of them. How many rivers were polluted with crude oil and phosphates? Crude oil and phosphates. So that has to be polluted with both. So that's crude oil and phosphates. Well, that's the A plus B. That has to be that 150 number. So 150 rivers. Then how many rivers were polluted with only sulfur compounds? So only sulfur compounds was this portion of our Venn diagram, and that's the 211. Okay, so the questions are easy once we got the Venn diagram working out for us. And the last one, 100 people were asked whether they knew who any of the following are: Loki, Hermes, and Ra. Provide a Venn diagram that accurately depicts the following data. They then answer the questions that follow. So this is a similar exercise. We have Loki, Hermes, and Ra. Let's go with 3 circles. I'm going to make nicer circles this time. Okay, and let's make that one a little bit bigger and get them to overlap a little bit better. Okay, here we go. There's our 3 circles. I'm just going to use first letters for each of these. So this will be the Loki circle, this will be the Hermes circle, and this will be the Ra circle. And this is in the context of some sort of universe. Okay, I learned from the last one. Give myself plenty of space here to do some work over here. Okay, 25 people did not know any of these. So we have 25 people outside, but still in the universe. 3 people knew all 3. So that puts the 3 right in the middle. 48 people knew who Hermes or Ra were, but did not know who Loki was. So we have 48 people who are in the Hermes and Ra, but not in the Loki. So that's those 3. We're going to have to keep that in mind, that those need to add to 48. And let's do this idea where we cross things off that we've used up already. 40 people knew who Ra was. So the Ra total, those 4 have to add to 40. So we're going to come back to that one as well. 21 people knew who at least 2 of these were. Ooh, that's an interesting question. Knew at least 2 of the 3. So this is the area that, this is the part that knew who Loki and Hermes but not Ra. This is Loki and Ra but not Hermes. This is Hermes and Ra but not Loki, and this is all 3. So to say they knew at least 2 of these would be those 4 numbers there, one of which we know right now, the 3. So keep that in mind. And 7 people knew who Loki and Ra were, but did not know who Hermes was. 7 people knew who Loki and Ra were, but did not know who Hermes was. So that's the 7 is going to be here. No Loki and Ra, but not in the Hermes. And 8 people knew who Loki and Hermes were. Loki and Hermes are these 2 dots. That has to be 8. So be careful you don't put the, oops, I didn't mean to get rid of that 3. Don't carefully just throw an 8 right here and thinking, oh, that's Loki and Hermes. Because if you put the 8 there, that means that they also didn't know Ra, and this doesn't say that. This just says 8 people knew who Loki and Hermes were. They don't say that those same 8 people did not know Ra. So be very careful. We know that this plus this has to be 8. So I'm going to start putting in some variables of the parts we don't know. Let's do A, B, C, D, and E. And let's start with this bottom one. This is going to be the easy one. We know that B plus 3 have to be 8, so B has to be 5. So that gives me one of them. B has to be 5. Okay. And that means I've used up this information. I think we're in a position now to do the one who knew at least, this 21 people knew at least 2 of the 3, because that was those 4 things added together. So we can make an equation out of that. We know that 7 plus 3 plus 5, I'll just go ahead and add those up right now. 7 plus 3 plus 5 is 15, plus D has to be that 21 figure, so D has to be 6. Okay. And that uses up this information. And D has to be 6, okay? So we're just down to A, C, and E. Let's go to the, oh, I also used up that one. I forgot to cross that out. Let's go to this 40. 40 people knew who Ra was. That means I have to add up those 4 numbers and get 40. Well, 3 of those 4 numbers I now know, so we can do that. we have 7 plus 3 plus 6, that's 16. Add that to E, and that's going to give us the 40 people. So subtract the 16, and we have 24 people are in this E portion. So E is 24. And I've now used up this bit of information. Now let's do that last one. 48 people knew who Hermes or Ra were, but did not know who Loki was. Now, if you recall, that was, they have to be in Hermes and Ra, but not in Loki. So those three numbers have to add to the 48. And I know 2 of the 3, so let's box that. So we know that C plus D, which is 6. Let me just add these together. 6 and 24 is 30, so C plus 30 has to be equal to this 48 figure, so C has to be 18. And finally, we just got one left to figure out, A. And that's going to be based off this information here. I've used that, by the way. So we know that 100 total people should be in this Venn diagram. So everything added together, including this 25, including the A, have to add to 100. Well, let's see, what was the Ra circle? How many people knew Ra? That was 40, right? So there are 40 in the Ra circle. So let's just get that out of the way. There's 40 plus. Then we had another 23 right here. Then we had this 25 out here, plus this A. Oops, that didn't work out well. Plus A, and that has to be equal to the 100 total people in the survey. So I did, just verifying, I did everything in the Ra circle, which is 40, plus those two, plus that have to be 100. And these add to what? This is that 65 plus another 23 is 60 or 88. So we have 88 plus A has to be 100. Therefore A has to be 12. Okay, just double checking my arithmetic. Looks okay. Hopefully I don't make a mistake. If I do make a mistake in any of these videos, I'm human, I make mistakes, feel free to call me out in an email and we'll get things corrected for the class. Okay, I think we have a Venn diagram that we can work with now. How many people knew of only Hermes? Well, that's just, only Hermes is this part. So 18 people. How many people knew of Hermes and Ra? Okay, so this doesn't say only Hermes and Ra, it just says how many knew of Hermes and Ra. So that's going to be anything that's in the Hermes and Ra combined. So all 6 of those numbers are the people who knew of Hermes. Oh, no, sorry, I read that wrong. I read that as Hermes or Ra. How many people knew Hermes and Ra is just the people in their overlap. Ra in overlap with Hermes. So that's 3 plus that 6. So that gives us 9 people. Yeah, these words are important, aren't they? If that said or, it'd be a different approach. But and changes things. How many people knew of only Loki? Okay, so only Loki was the last thing we actually figured out was A, right? Just that number there is only Loki. So they don't know Hermes, they don't know Ra. And that's going to be the 12 people. Okay, and that is our